In 1944, during the fighting in Normandy, British tank units were getting absolutely hammered. Shermans and Cromwells would burst into flames after just one hit from a German shell, while their own return fire bounced harmlessly off the front armor of Panthers and Tigers. Because getting out of a knocked-out tank was such a nightmare, crew losses stayed painfully high for the entire campaign. The military told industry in no uncertain terms, "Build us a tank that can actually stand up to heavy German armor." As it turned out, engineers already had one in the works, the A34 Comet, the most technologically advanced British tank of its day. But instead of rushing it to the front, Command made the surprising decision to hold it back, keeping it in reserve until the time was right. The story of how this tank came to be is closely tied to Britain's own infrastructure limitations. British engineers knew full well their tanks couldn't match their German counterparts on a technical level, but they were dealing with some very real constraints. Railway flat cars in the UK were narrower than those used in continental Europe, which put a hard limit on how wide any tank could be. A wide tank simply wouldn't fit on the train, and if it didn't fit on a train, it wasn't going anywhere. Rail was still the absolute backbone of production logistics and military supply chains. German factories had the luxury of building massive tanks because the European rail network could actually handle moving them around. British designers, on the other hand, had to squeeze every new project into those narrow loading gauges. At first, the Cromwell tank looked like a solid answer to the problem. Powered by a Rolls-Royce Meteor engine, it was quick and nimble. Early versions could hit up to 40 miles an hour on a good road, though that actually proved too fast for the suspension. But its 75mm gun just couldn't deal with heavy German armor. Shells bounced off the frontal plates of Panther tanks without doing a thing. Tank crews were forced to close in on the enemy to dangerously short ranges or try flanking maneuvers, risking return fire the whole time. Losses kept climbing, and it became painfully clear that the Cromwell had hit its design ceiling. In parallel, Vickers Armstrong had been developing a compact, high-velocity 75mm tank gun that promised real anti-armor punch. The catch? Even this weapon proved too large for the Cromwell's turret ring. The breech was too long, the recoil mechanisms too bulky. No amount of clever engineering could cram this gun into the existing design. They could have enlarged the turret, sure, but that meant widening the hull, which would inevitably blow right past the railway transport limits. It was a complex engineering puzzle with no easy answer. The breakthrough came from the team at Leyland in Lancashire. Rather than trying to upgrade the old model, they proposed building a completely new tank from the ground up, designed from scratch specifically around this powerful armament. At the same time, the new vehicle had to keep everything that made its predecessor great: speed, agility, and a dependable power plant. The main requirement was that it still had to fit on those railway flat cars, while carrying a gun that could knock out heavy tanks like the Tiger and the Panther. Command designated it the A34 and called it the Comet. Work kicked off in early 1943. From day one, the engineers understood just how tough this job was going to be. They had to design a compact turret for a big gun while still giving the crew proper working conditions inside. The loader needed enough space to handle heavy shells efficiently. The gunner needed clear access to the sights and aiming mechanisms, and the commander needed a full 360 view of the battlefield. In the end, the designers chose a technical approach that researchers would later call nothing short of revolutionary. Engineers came up with a new, lower-profile turret with a cast gun mantlet that made it possible to mount a large gun in a moderately sized turret while still keeping the standard elevation and depression angles. The turret was electrically traversed, a feature borrowed from the Churchill tank, and ammunition was stored in armored bins. Designers would later build on these same ideas for the Centurion tank, but the Comet got there first. The hull was completely welded, not a single rivet in the entire structure. That was a massive technical leap forward compared to the Cromwell and other British tanks of the period. Welded seams held up way better than riveted joints, because when a shell hit riveted armor, Those rivets turned into deadly shrapnel flying around inside the crew compartment. The front of the hull got a distinctive stepped shape, and armor thickness in the most exposed and vulnerable areas was bumped up to 102 millimeters. By the fall of 1944, the first production Comets were rolling off the factory line. But Command didn't rush them to the front. They made a different call entirely. The tanks stayed back in Britain while crews went through intensive training. That meant tankers had to keep fighting across France and Belgium in outdated machines, and the resulting losses were heavy. Command had their reasons, though, and those would soon become clear. For the Comet's main weapon, the developers chose a gun that technically didn't even exist yet. A 77mm gun wasn't in any British Army inventory, so on the official paperwork, the military logged it under a specially created designation. The story behind this weapon is a great example of engineers thinking outside the box. The Army already had a hard-hitting anti-tank gun, the 17-pounder, with a 76.2mm caliber. This weapon was being mounted on the Sherman Firefly, and it could reliably punch through enemy armor at ranges of up to 1.5 kilometers. The main issue was size. The 17-pounder used a single-piece round that was just too long for a compact turret. The loader simply didn't have enough room to wrestle a shell like that in such a tight space. And at the same time, designers couldn't make the turret any bigger without busting the railway clearance limits. The solution came from Vickers, who had been working on their compact high-velocity gun. Someone had the idea to increase the bore from 75 to 76.2 millimeters, the same caliber as the 17-pounder. That way the gun could fire the same projectiles, taking advantage of any advances in 17-pounder ammo. For the cartridge case, they used a shorter casing from the old 3-inch 2000 weight anti-aircraft gun, loaded to higher pressures. The result was a brand new round that kept the penetrating punch of the 17-pounder, but was compact enough for the crew to handle in cramped quarters. The shorter casing held less propellant, which meant a slight drop in muzzle velocity. But the developers compensated for that by designing the barrel specifically for the modified ammo, and the overall package also improved turret balance and made the gunner's life a whole lot easier. The end result was that the Comet's gun was only slightly behind the Sherman Firefly in raw armor penetration, but it was significantly more accurate. This edge really showed when using high-explosive rounds. Because the 17-pounder had been designed purely as an anti-tank weapon, its high-explosive ammo was pretty much underwhelming. The Comet's gun was built to be a truly versatile weapon, effective against armor, infantry, and field fortifications alike. For the first time, crews had a machine that could handle the full spectrum of combat missions without having to choose between punching through armor and blasting fortifications. They called the gun a 77mm, even though its true caliber was 76.2, and that was for a purely practical reason. The military wanted to prevent logistical mix-ups, since the Comet's ammo didn't fit either the standard 17-pounder or American guns of the same caliber. By giving the gun a unique designation, supply units could make sure the right shells got to the right units at the front. The tank carried a 5-man crew, commander, gunner, and loader up in the turret. A commander's cupola with a full 360 view let him scan the battlefield without poking his head out of the hatch under enemy fire. That was a major step up from the Cromwell and many other tanks of the era, where crews had to physically expose themselves to direct danger just to get a decent look at their surroundings. Down in the front of the hull sat the driver on the right and the bow gunner radio operator on the left. The gunner manned a Bisa hull machine gun mounted in a ball mount in the left side of the hull front. While some experts knocked this layout as outdated, actual combat showed it worked. The hull machine gun let them suppress enemy infantry without swinging the main turret around, especially handy in urban fighting. The Comet inherited its power plant from its predecessor, with almost no changes. A 12-cylinder Rolls-Royce Meteor engine cranked out 600 horsepower, giving the roughly 33-ton machine plenty of speed. The Merritt Brown transmission sat in the rear of the hull, with 5 forward gears and 1 reverse, for the upper track run. They did this for the upper track run. They did this because the track width had been bumped up to just over 450 millimeters. Wider tracks lowered ground pressure and improved cross-country mobility, but they also put extra strain on the road wheels. The return rollers solved that problem, even though later testing showed the tank ran just fine without them. The armor layout was a smart trade-off between protection and mobility. The front hull was 74 millimeters thick, the sides 32. The turret ranged from 63 to 102 millimeters around the gun mantlet. This didn't make the tank bulletproof against German guns, but it gave the crew a fighting chance of surviving a hit at medium and long ranges. Leyland factories ramped up production, and by late 1944, the Army started receiving its first vehicles. Factories produced about 1,200 Comets in total, but getting them to the front took longer than expected. Command held off on sending the new tanks into combat, and there was a good reason for that. In December 1944, the situation on the Western Front changed rapidly. The German Army launched a massive counterattack in the Ardennes, punching through the Allied front line. American divisions were surrounded, and command urgently rushed British armored units to the most threatened sectors. It was right then that the 11th Armored Division received its new Comets, but command never gave the green light to send them into battle. The reasoning was straightforward. The new tanks required crew retraining, and throwing unprepared tankers against experienced German units would only mean losing expensive new equipment for nothing. Officers decided to wait a few weeks, build up fully combat-ready units, and avoid wasting their newest tanks in the chaos of battle. While Sherman and Cromwell crews fought to hold back the German advance, Comet tankers were mastering their new vehicles at training grounds in Belgium and northern France. The program covered driving, gunnery, and the ins and outs of the new weapon system. Crews practiced working together inside the tank and learned how to exploit their machine's technical advantages. Instructors put especially heavy emphasis on tactics for fighting heavy German armor. They made it clear that the Comet wasn't built for head-on duels with Tigers and Panthers. Instead, crews were taught to rely on speed, maneuverability, and their accurate gun hitting the enemy from the flanks or from carefully chosen ambush positions. The first real combat for these tanks came in March 1945. The 11th Armored Division crossed the Rhine near Wesel and pushed deeper into Germany. Comets rolled in the very first wave. German troops were encountering them for the first time during this offensive. British command gave the tanks high marks for their performance. Unlike Cromwell crews, who had to close the distance to the enemy, Comet crews were laying down effective fire from 1.5 kilometers out. Their shells punched through the side armor of Panthers and the frontal armor of older Panzer IVs on the very first hit. German tankers, who had previously held a comfortable range advantage over British armor, suddenly found themselves facing a completely new tactical reality. An enemy that could knock out their machines before they even got within their own effective firing range. Meanwhile, the 29th Armored Brigade was operating along the main axis of the attack. This brigade's tanks broke through German defensive lines using a combination of firepower and mobility. Where Sherman's and Cromwell's got bogged down in static firefights, Comet crews bypassed enemy strongpoints and hit them from behind. German infantry units were forced to pull back unless they had heavy anti-tank weapons capable of stopping the advance. The tanks also proved exceptionally good at moving over rough terrain. The Christie suspension let the Comets travel off-road at speeds that most German tanks simply couldn't touch. Heavy Tigers bogged down in the spring mud, while the British machines plowed right through without slowing down. Their wide tracks spread the tank's weight over a bigger area, so where Panthers sank up to their road wheels in the dirt, the Comets just kept rolling forward. Combat losses were inevitable, though. German infantry was using Panzerfausts in massive numbers, and these cheap, disposable anti-tank weapons posed a deadly threat to any tank, regardless of how thick its armor was. Several Comets were lost to hits on the sides and rear, where the shaped charge easily punched right through. Crews quickly learned to work tight with their infantry support. Soldiers would sweep roadside bushes and wrecked buildings, flushing out hidden ambushers. The battles for river and canal crossings in northern Germany highlighted another strength of the new tanks. The 77mm high-explosive rounds proved highly effective against infantry positions and light-field fortifications. Where the 17-pounder on the Firefly did little damage against dug-in troops, the Comet could knock out dugouts and machine gun nests with just a few well-placed shots. The 3rd Royal Tank Regiment received their Comets right in the middle of an active offensive and put them straight into action. Even with minimal crew training time, the tanks performed impressively well. Crews quickly grew to love the roomy fighting compartment, the comfortable commander's cupola, and the reliable transmission. Compared to the high-maintenance Cromwells, the Comet was rock-solid dependable and showed exemplary reliability. In April 1945, the rapid dash eastward began. As German resistance crumbled day by day, Allied armored columns were covering 50 to 70 kilometers a day. The Comets were perfectly suited for exactly this kind of sustained operation. Their engines handled hours of continuous driving without complaint, and the cruising range let crews operate independently without having to wait for fuel supply trucks to catch up. By the time Germany surrendered, British armored units had already reached the banks of the Elbe River. Some units rolled into the outskirts of Hamburg, while others took up positions directly facing Soviet forces. The war in Europe was over, but the Comet story was just getting started. Ahead lay new conflicts, new theaters of war, and entirely new challenges for this machine. Berlin lay in ruins, and the victorious Allies were carving up the capital of the former Reich into occupation zones. The British sector needed a strong military presence, so command put together a specialized unit for duty right in the heart of Germany. The Berlin Squadron of the Royal Tank Regiment was issued brand new Model B Comets. These machines were there to project British military strength on the streets of the devastated city. The differences between the Model A and Model B were easy to spot, even for a casual observer. The early tanks had exhaust pipes that stuck straight up over the engine deck, just like on the Cromwells. That gave them a distinctive look, but it also caused real problems. The hot exhaust gave away the tank's position in infrared, and the pipes were totally exposed to bullets and shrapnel. Engineers fitted the Model B with a completely redesigned exhaust system. 2 flat pipes, nicknamed fishtails for their shape, routed the exhaust through the rear hull plate. This made the vehicle harder to detect and protected the exhaust system from battle damage. Designers also rearranged some equipment on the track guards, making field maintenance much easier in dusty conditions. The Model A tanks that survived the final weeks of fighting were fitted with a so-called Normandy tail, an extra fuel tank bolted to the rear to extend range. The name stuck from when mechanics had fitted similar tanks to Cromwell's before the invasion of France. The Model B didn't need the Normandy tail anymore, since the new engine compartment layout let designers simply make the standard fuel tanks bigger. Peacetime duty in Germany was a world apart from active combat. Crews patrolled streets, guarded key facilities, and served as a visible show of military force. Comet tanks regularly appeared in parades and inspections, drawing the attention of both locals and Allied troops alike. Across the dividing line, the Soviets were also taking a professional interest in these unfamiliar machines. As the Cold War ramped up, former wartime allies gradually became potential adversaries. British tank units stationed in Germany began preparing for a possible confrontation, and the Comet served as their primary battle tank right up until the Centurions arrived. Command regularly ran training exercises where crews rehearsed defensive tactics along the most likely routes of a potential advance from the east. Meanwhile, British industry kept refining the vehicles. Engineers upgraded some tanks with reinforced suspension and outfitted others with new communication equipment. Eventually, specialized variants appeared. command tanks fitted with extra radios, and forward artillery observation vehicles, kitted out with upgraded optics. The basic platform proved versatile and flexible enough for all these modifications without needing any major redesign work. Exports also played a significant role in extending the tank's operational life. Great Britain was looking to strengthen ties with its NATO partners, and supplying current armored vehicles directly supported that strategic goal. Finland, which maintained its neutrality but wanted to safeguard against outside pressure, bought a batch of Comets to beef up its armored forces. Ireland, which traditionally kept its distance from the British military sphere of influence, also purchased a few vehicles. The Union of South Africa received Comets to replace their aging Shermans. A newly independent Burma folded the hardware into its freshly formed army. Cuba also picked up a small batch around that time for its own armed forces. The exports reached 4 continents, and everywhere it went, the Comet proved to be a tough and reliable machine. Portugal deployed these tanks to its African territories, where crews patrolled dirt roads and conducted counterinsurgency operations. The climate of equatorial Africa was a brutal test for a vehicle originally designed for European conditions. Engines overheated, laterite dust choked the filters, and the blazing sun dried out the rubber seals. But the fundamental design held up. When Centurion tanks started showing up across the board, British armored forces began phasing the Comet out of frontline service. The new machine was better in every way: firepower, armor, and mobility. But the older tanks weren't done yet. They'd keep serving for a long time. At first, the tanks were handed down to territorial units. Instructors used them for crew training, and troops operated them in areas where the chance of running into modern enemy armor was minimal. On June 25, 1950, North Korean forces crossed the 38th parallel and drove south down the peninsula. The United Nations authorized military intervention, and Great Britain deployed its units as part of the international coalition. But the tanks Britain sent to Korea weren't Comets. They were the newer Centurions. The 8th King's Royal Irish Hussars sailed for Korea with Centurion Mark IIIs, and it was these machines that would make their name in the brutal mountain fighting of the peninsula. The Comet by this point was already being phased out of the front line in favor of its more capable successor. That didn't mean the Comet was sitting idle. In Germany, British armored units still relied on them for garrison duty, training exercises, and readiness along the Iron Curtain. In Hong Kong, Comets of the 1st Royal Tank Regiment stood guard against a potential incursion from mainland China well into the late 50s. Crews trained in mountainous terrain, practicing how to defend narrow valleys and mountain passes. The threat felt very real after the change of government on the mainland, and having tanks on the border served as a serious deterrent. When Centurions finally arrived to replace them, the older machines were handed down yet again, this time to territorial and reserve units across the Commonwealth. The last Comets left British frontline units in the late 50s, when the military fully transitioned to the newer Centurion tanks. But several other countries kept them in service much longer. Finland maintained Comets on its border right into the 70s, and armed forces in some Asian and African countries held onto them even longer than that. The Burmese army, for example, actively used Comets during prolonged fighting with rebels in the jungles near the Thai border. Tanks that designers had built primarily for European terrain ended up pushing through tropical undergrowth, crossing muddy rivers, and supporting infantry assaults on fortified guerrilla camps. Despite the brutal effects of the harsh, humid climate, the machines kept running, a testament to the incredible durability that British engineers had baked into the original design. In some countries, Comets remained in active service as late as the 1980s, long after they had any business being on a battlefield. By that point, a tank designed right in the middle of World War II was completely obsolete. Modern anti-tank missiles and RPGs could easily slice through the armor that had once given crews reliable protection from enemy fire. The era of the Comet had come and gone, and defense departments gradually sent the surviving vehicles off to museums, or simply scrapped them to be melted down. That was the end of the road for a machine that showed up too late to fight in the biggest battles of its war, but still proved itself in conflicts around the globe. Today, historians and engineers study the Comet as an important stepping stone in the evolution of armored vehicles. A perfect example of how wartime engineers tackled the challenge of balancing speed, armor, and firepower.